Okay, so let's proceed with bonding concept now. So this concept is a precursor to your Lewis structure, no? I don't know if na-discuss na siya, but yun yung idea, no? So before you draw the Lewis structure, you should be able to recall your bonding concepts, no? I know you were able to discuss this in your high school. For 2 times. Junior high school ko lang, I mean third year high school ko to natutunan. So kayo, 2 times nyo to natutunan for sure. Junior high school and senior high school, no? And so ngayon, babalikan uli natin siya for the third time. Okay? So let's go to the bonding concepts. The question is, one, why do atoms form compounds? Bakit kaya sila gusto mag-form ng compound? The answer is that they want to be stable, no? Parang tao lang din yan, no? So you're looking for your partner, let's say, kunwari, no? You're looking for your partner, your atom, no? Nakasama para maging stable. No? Yung, let's say, yung life nyo, kung gusto nyo maging ganun stable, edi sige, makipag-pair ka with other atoms, no? So ganun din yung concept ng atoms, no? So they want to achieve stability. That's why they form chemical compounds. Now, the question is, bakit? Okay. So let's look at our periodic table. So ito yung periodic table natin. All these all these atoms, no. I mean not all. Most of the atoms here do form chemical compounds, 'di ba? And the reason why is yun nga, number one, they want to be stable. In what sense? Paano siya magiging stable? Okay. So, ganito. Ang atoms kasi natin, they are trying to imitate something. So, may gusto sila gayahin, no? So, alin kaya dito yung gusto nilang gayahin na atoms? Anong group of atoms yung gusto nila gayahin? The answer would be the noble gases. No? So, our atoms want to imitate the noble gases. No? Gusto nila gayahin kung ano meron ang noble gases. Kumbaga sa tao, parang kayo yan, idol nyo, let's say, yung isang K-popper or yung isang American artist, no? So, if idol nyo yon, gusto nyo siya gayahin. Yung other atoms ng periodic table, itong mga to, yung mga other atoms na yan, gusto nila gayahin itong noble gas, no? Itong nasa group 8, no? Yan yung gusto nila gayahin, no? Ang tanong, paano? Paano nila gagayahin yan, no? So, ganito. Parang sa tao lang yan. If kayo may idol kayo, not necessarily naman na kailangan magbagong anyo kayo to be that new person. No? Hindi necessary na ganun. Kunwari, you idolize a K-pop artist, no? Or let's say an American artist, no? If you're idolizing someone, it doesn't necessarily mean that you will transform into that person. Walang ganun, no? Instead, ano gagawin nyo? You will just copy whatever that person is doing, no? How that person speaks, gagayahin nyo. Kaya yung iba sa inyo, nagko-Korean, no? No? As ano pa, how the person dresses, ginagaya nyo rin, no? Ano pa? Their lifestyle, ginagaya nyo, no? Through your, colors ng hair, your earrings, so on and so forth, no? So, yan. So, yun yung idea, no? If a person, no, is idolizing someone, ginagaya nyo yon. No? So, yung atoms din natin, they do the same. No? So, gagayahin ng mga atoms na to ang mga noble gases. But again, it doesn't necessarily mean that the atoms will transform into a noble gas. Hindi naman meaning nun na idol mo si ganitong artist is magbabagong anyo ka para maging ganong artist. No, no. Gagayahin mo lang siya. No? So, yung atoms natin, they will not change to be a noble gas. Gagayahin lang nila yung noble gas. No? Idol nila eh. Ang question is, anong gagayahin nila sa noble gas? No? What's with noble gas that the other atoms can imitate? Ano kaya pwede nila gayahin sa noble gases? Yung discussion to sa lecture nyo, electron, sa laboratory nyo, no? Yung electron configuration. Okay? So remember, our electron configuration varies with different number of electrons. No? So that means if an atom wants to imitate the noble gas, all that atom needs to do is that i-adjust niya yung electrons niya. Either mamigay siya ng electrons or tumanggap siya ng electrons para maging katulad ng noble gas configuration ang kanyang electron configuration. No? Para maging same-same sila ng electronic configuration. So by doing that, no, doon na-achieve yung stability. No? Okay, so by just copying the electron configuration of the noble gases, your atoms become stable. No? So stable na sila. No? Okay na sila. No? So meaning, kailangan magkaroon ng chemical reactions to create stable substances. No? So yun yung idea. No? That's the reason why we have chemical reactions. No? The electrons are being used to modify the electron configuration of atoms to copy or to imitate that of the noble gas. No? So gagayahin nila yung sa noble gas. No? Okay. So since nasabi na natin yung electron configuration, punta tayo sa electron configuration ulit. No? So let's have some atoms. No? Let's say lithium, sodium, lithium muna. Okay. So let's have lithium. How many electrons does a lithium atom contain? No? So if it is not charged, walang charge siya doon, it means if 3 yung atomic number niya, 3 din yung kanyang electrons. No? Pag walang charge. No? So in our case, walang charge. No? So that means this lithium atom contains 3 electrons. So what I'm going to do is I will distribute the 3 electrons into different orbitals na, the different energy levels na. So again, in your laboratory, alam nyo na yung alam nyo na yung pagkakasunod-sunod, di ba? Yung 1s2, 2s2, 2p6, something something, no? Okay, so ilalagay natin yung electrons doon, no? So I have 3 electrons and I will designate them onto different orbitals, no? Specific orbitals. And I will start with the lowest energy level first, which is the 1s orbital. The s orbital can hold 2 electrons, so that's 1s2. Okay. How about the extra electron? May isa pang sobra. That extra electron will occupy the next orbital, which is the 2s orbital. No? Ayan. Doon mapupunta yung isang sobrang electron. So 1s2, 2s2. Isa pa, sodium. So sodium, since this is not a charged particle, that means the number of proton corresponds to the number of electrons. So since wala yung charge, 11 din yung electrons niya. Paano malalaman yung charge? Just look at the top right number. Pag may positive dyan, may charge yan. Pag may negative yan, may charge yan. Pag may positive charge dyan, meaning yan, nabawasan yung atom ng electron. Pag negative yan, meaning nadagdagan yung atom ng electron. So, yun lang yung keywords, visual cues natin. Okay, so yan. So, let's have sodium. Okay. So, let's have sodium. We have 11 electrons to distribute. So, we will start with the lowest energy level, 1s. And it can contain 2 electrons, diba? So 1s2. Next orbital is the 2s. It can hold 2 electrons. Then may sobra pa tayo na 7 electrons. So I will proceed with the 2p6. So sobra pa ng isa. So ilalagay ko na yon sa 3s1. Okay. So these are our electron configurations. No? Okay. So our electron configurations can be compressed, no? Paano yung compressed, no? Pwede natin paigsiin yung electron configuration into a shorter notation, no? Signifying the noble gas configuration. Paano yun, no? Okay. Sa ating electrons kasi, dalawang parte yan, no? Ano yung first part ng electron configuration? You have your inner configuration. And you have your outer configuration or the valence electrons. So two parts yan, no? We have the inner configuration and the outer electrons or the valence electrons, no? When we say inner configurations, these are the electrons that correspond to a noble gas, no? So when we say ay, and so when we say inner configuration, that means we are pertaining to the electron configuration or the electrons that correspond to the noble gases, no? So anything beyond that is your valence electrons. Yung mga lumalagpas na dyan sa noble gas, valence electrons na yun. And these electrons are used in chemical reactions. Okay? So, yan. Ngayon, ang goal natin is to trace where are the inner configurations, where are the noble gas configurations here. One technique is for you to memorize the electron configuration for the noble gases. But again, wag nakakamatay 'yon, no? Wag magkabisado ng mga bagay na simple lang naman ng idea, no? So, instead of us memorizing the electron configuration of the noble gases, may technique akong ipapakita sa inyo. Although alam nyo na to, na. So, number one technique is just to identify the atomic number of your noble gases, no? Okay, so for example, I have 2 for helium. That means that my second electron in my electronic configuration corresponds to helium. Okay? So if I have 2 electrons sa electronic configuration, meaning nun, helium yung katumbas nun. Yun yung kanyang counterpart. No? Pag 10 electron, that corresponds to neon. Pag 18 yung electrons, that corresponds to argon. Pag 36, that corresponds to krypton, so on and so forth. No? So all you have to do is to just look at the periodic table, identify the atomic numbers, no? The 2, napindot. So yun, 2, 10, 18, 36, no? So alamin mo lang yung kanilang atomic number, then you start counting the electrons, no? So ayan, balik tayo dito. So again, ano yung first noble gas? Helium. The atomic number of helium is 2. That means the second electron here in our electron configuration, that corresponds to helium. Meaning, yung 2, itong 1s2, ito yung first 2 electrons natin, this corresponds to a noble gas, helium. Ganon din dito sa baba, no? Yung 1s2 na yan, helium yung katumbas niyan. Okay? So for lithium, wala na, no? 3 lang yung electron eh. So hanggang lithium lang siya, 'di ba? But let's proceed with sodium. So sodium, helium ito, no? Yung second electron ay helium ang katumbas na. The next noble gas is neon, which has an atomic number of 10. That means the 10th electron in our electron configuration that corresponds to neon, no? So magbibilang tayo ng up to 10 electrons. So this is 2, 4, 10. So that means dito sa 2p6, that corresponds to the neon gas, no? Or the neon configuration. So yun yung technique, no? You just identify the atomic number, then you count the electrons. Pag naging sakto yan doon, hanggang doon yung inner configuration natin. Yun yung noble gas configuration. Okay? Mamaya may onting practice pa tayo dyan, no? So, yun lang yung idea, no? So now, since we are able to identify the configuration that corresponds to noble gas, we can condense this, we can condense our electron configuration. Pwede natin siya paigsiin, no? So, paano yan pinapaigsi, no? So, we copy the noble gas, no? Yung configuration na nagko-correspond sa noble gas, i-represent natin yon as the noble gas atom mismo, no? So, i-enclose natin siya sa square bracket, helium. Then, anything outside that will be our valence electrons, no? So, isusulat mo yung valence electron, 2s1. Helium, 2s1. So, ganun, no? Ganun yung pag-condense na ito papunta sa ganitong style, no? Yung makikita mo yung inner configuration. Okay, so let's try this one, the sodium. Ang pinaka-last na noble gas na nadaanan niya is the neon, no? So that means my inner configuration would be neon. Anything outside it will be my valence electrons, 3s1. Okay? So ito na yung shortened version, no? So this is lithium. Ang kanyang electronic configuration ay helium 2s1. And sodium, ang kanyang electronic configuration now would be neon 3s1, no? And that is actually written in your periodic table, no? So pag tinatamad kayo, ayan, no? Helium 2s1, neon 3s1, so on and so forth, no? So ganun na. So ganun yung way kaya nakuha yan. Okay, so yan. Bago tayo mag-proceed sa mismong topic, practice pa muna natin yung pag-condense ng ating equations, no? Practice pa tayo. Dito naman sa gilid. So let's have fluorine. Ay, ba't red? Ay, wait lang ha. Ayan, so fluorine. So our fluorine, the atomic number is 9. That means the electron is also 9. No? So I have 9 electrons to distribute. No? So I will start distributing the electrons from the lowest energy level, 1s2, yung excess sa second energy level, 2p5. No? So 2p5 lang. No? So 2, 4, 5. 2, 4, 5. 2, 4, 9 pala. So yan. So yan. Fluorine na nga. So 2, 4, 9. Okay. Wala lang ako. So yan yung idea, no? So this is the electron configuration for fluorine, no? And now, we are going to trace where the noble gas is, no? Asan kaya yung mga noble gases? So again, yung second electron that will correspond to helium. So this means this corresponds to helium. Ano yung sumunod na noble gas? 10th electron. The problem here is 9 lang yung electrons natin, okay? So stop na tayo dyan sa helium. I will represent this as helium 2s2 2p5 na. So yan, stop na ako dyan. Where I have 7 valence electrons na. So paano sir nabibilang yung valence electrons? Just count the exponents. This is 2, this is 5, add them, you have 7 na. And ano pa? Let's say chlorine. So for chlorine na walang charge, I have 17 electrons. Again, the atomic number will correspond to the electrons, no? Provided that the atom doesn't have any charge. Okay? So 17 electrons. Distribute natin yan. 1s2, 2s2, 2p6, ilan na yan? 10. 3s2, ilan na yan? 12. Ilan na lang kulang? 5, no? So 3p5, no? Okay. So that is the electron configuration of chlorine. Then let's trace the noble gases. Asan yung mga noble gases? On the second electron, I will find helium. Ano sumunod? 10th electron. The 10th electron will correspond to the noble gas neon. Diba? So yan. Ano yung next na noble gas? 18. Sadly, 17 lang electrons natin. So stop na tayo doon. Hindi natin ma-achieve yung argon configuration. Okay, so stop na tayo dyan. That means we can write this as neon 3s2, 3p5 now, which contains 7 valence electrons. No? Okay. So ayan yung idea. No? So ayan yung mga pinagagawa natin. No? Teka, urong natin dito. At pala sa baba ko na siya nilagay. Okay, so that's the idea, no, na meron tayo, no? We can write the electron configuration into condensed form, no, wherein we can see the noble gas configuration. No? Again, anong gusto ng atoms? They want to be stable. Stable in such way that their electron configuration would be the same as the noble gases configuration. No? So kailangan yung electron configuration nila ay yung noble gas configuration. So let's look at lithium. So looking at lithium, ito yung kanyang electron configuration. Helium 2s1. For lithium to be stable, dalawa yung option niya. Yan, magkakaroon tayo ng onting dilemma. No? So yan, kunwari ikaw si lithium, gusto mo maging stable, ito options, mamili ka ng isa. No? So ano yung mga pagpipilian? Lithium can choose to give off one electron. No? Pwede niya ipamigay yung isang electron. Anong electron? Itong valence electron niya. Bakit? Ano mangyayari? Kapag pinamigay niya ay yung one electron niya, ano mangyayari sa noble gas? Ano mangyayari sa kanyang electronic configuration? Mawawala na to, no? Mawawala na yung 2s1 na yan, no? So that means, pag binigay ni lithium yung kanyang one valence electrons, one valence electron, ano mangyayari sa kanyang electronic configuration? Magiging noble gas na. So yan yung isang option ni lithium. Ipamigay niya yung isang valence electron. So its electron configuration will now be that of the noble gas. No? Yan, noble gas na siya niyan. Okay na siya nun. Stable na siya. Ito pa yung isang option niya. The next option is to accept 7 electrons. Bakit? Ano ba yung next noble gas? No? Sa helium, ang next ay si lithium. Si neon. No? So si neon, ika-10 electron yon, di ba? So that's 10 minus 3, 7. So 7 pa yung kailangan niya tanggapin, no? So if lithium chooses to accept 7 electrons, its electron configuration will be the same of the neons, no? So magiging pareha siya ng kay neon. So yan, yun yung options niya. Magbigay ng isang electron or tumanggap ng 7. Pag nagbigay siya ng 1 electron, its electron configuration will be helium. Pag tumanggap siya ng 7, magiging neon yung kanyang electron configuration. Mamili tayo. Saan mas madali? Siyempre, ang mas madali ay yung onting effort lang. So lithium will choose to give 1 electron na lang. Bakit? Kasi kapag tumanggap siya ng 7, ang dami nun eh. Ang dami ng 7. So, ang daming steps. Kumbaga, ito yung isang step. You go back 1 step or you go forward with 7 steps. Ano yung mas nakakapagod? E di mas maraming step, no? So, si lithium, tamad yan, no? In the sense na ayaw niya pumunta doon sa 7, no? Andito naman yung isa eh, no? Andito naman si helium, no? So, gagawin niya, bigay na lang niya yung isang electron niya. So, ang kanyang electronic configuration ay magiging helium na, no? So, ito yung pipiliin niya, no? So, lithium will choose to give off 1 electron instead, no? Okay? So, ano mangyari kay lithium? As lithium gives off its 1 electron, so let's call it. Pag si lithium, binigay niya yung isang valence electron niya. Kunwari, binigay niya, ginive off niya, what will happen? Mawawala na yan, no? May ganito na lang si helium. But, ang magiging counterpart niyan is ganito, no? Since lithium lost 1 electron, what will happen to the charge, no? Again, no, kung naalala nyo pa, charge is equals to proton minus electron, no? Sa lab 2 eh. Okay, so charge equals proton minus electron. Kapag mas maraming proton, positive yung charge ng iyong atom, no? Kapag nabawasan ka ng electron, meaning lumiit yung number 4e, magiging positive charge din ang iyong atom, no? So what happened here? Lithium just lost an electron. Nawala yung electron. So what will happen to the charge, no? Since nabawasan ng isang electron siya, the charge will increase by 1. Magiging positively charged na si lithium. Okay? So every time you lose an electron, that corresponds to a positive charge, no? So yun. So yan yung choice niya kasi yan yung pinakamadaling option, no? So let's have another one, si sodium. Okay, si sodium, neon 3s1. Dalawa options niya. Parang yung kay lithium. Give off 1 electron or accept 7 electrons. But if sodium chooses to give off 1 electron, its electronic configuration will be the same as neon. Pag pinamigay niya iyan, magiging neon yung kanyang electron configuration. If tumanggap siya ng 7 electrons, magkakaroon na siya ng 18 electrons in total, which will correspond to argon. So mamimili siya. Ano yung mas maganda? Magbigay ng isa or tumanggap ng 7, no? To take 1 step backwards or to take 7 steps forward. Ito yung easier, no? Ano yung easier? Umatras na lang ng isang beses, no? So sodium will choose to give off its electron, no? So ipapamigay niya itong 3s1 yan, no? So yan, so sulat natin. As sodium chooses to give off that electron, that valence electron, what will happen is that its its electron configuration will be the same as the noble gas neon, no? So mawawala na yung outer electrons eh. Inner electrons na lang matitira, which corresponds to neon. And again, in ano, as a consequence, no? Wala na ako ng words, no? So as a consequence, since sodium lost 1 electron, the charge will be positive 1, no? So again, every time you lose an electron, that corresponds to a positive charge, no? Okay, so yan. So yan, by losing an electron, sodium will be a noble gas configuration, no? So yan, satisfied na siya dyan. Stable na siya. Okay? So, yung kinuha nating examples kanina, fluorine. Ano yun? Helium 2s2 2p5. Si chlorine. Neon 3s2 3p5 na. Okay. So, yan. So, let's have fluorine. Baba ko lang tong isa. Okay, so let's have fluorine. Dalawa uli options niya. Pwede siya mag-lose ng 7 electrons. Ano yung purpose? Para itong mga to, mawala, ang matira ay helium configuration. So if fluorine loses 7 electrons, its electron configuration will be the same as helium's notation. So magiging ano yan, magiging same siya ng kay helium pag tinanggal niya yan lahat. Ano isang option niya pa? Gain 1 electron. No? So yan, so gain 1 electron. Bakit? Ano ba yung next noble gas? After helium, si neon ang next noble gas, di ba? Ano yung atomic number niya? 10. So that means for the 10th electron sa electronic configuration, pag 10 na yung electron sa electronic configuration, that will correspond to neon, no? So siyam na to. Ilang electrons na lang kulang? Isa. So if fluorine chooses to accept 1 electron, its noble gas configuration will be neon. Okay. May 10 na yung electron niya eh. Again, pag 10 yung electron, neon yung katumbas. No? So ano yung mas madali? To lose 7 or to gain 1? E di syempre, yung mag-gain ng isa. No? So that's why fluorine will accept the electron. No? So as it accepts the electron, ano mangyayari sa kanyang electron configuration? 2p. Yung 5, madadagdagan ng isa. So, magiging 2p6 na yan. Teka lang. 2p6. And saan uli nagko-correspond kapag 10th electron? Kay neon. Na? So, yun. So, if fluorine chooses to gain 1 electron, madadagdagan siya dito sa 5. Instead ng 5 yan, 6 na. And then, since 10 na yung electron niya, neon na yung katumbas nun. Okay? Ano yung consequence? As a consequence, since fluorine gained electron, tignan natin yung equation again. If you increase the number of electrons with the same proton, lalaki yung number dito sa negative sign. That means if you add the two, negative yung answer, no? So ano lang yung point, no? The point is if you accept electron, you become negative, no? Ayan. So magiging negative yan pag nag-accept ng electron or nag-gain ng electron. By how much? Edi kung ilan yung in-accept mo. Kunwari, fluorine chooses to accept 3 electrons, edi magiging negative 3 yung charge niya. Kunwari, 2 electrons tinanggap niya, edi negative 2. Kunwari, nag-lose siya ng 3 electrons, edi positive 3. So on and so forth na. So yun lang yung concept na. And last one, we have chlorine. No? So chlorine, ganun din yung dilemma. Either chlorine chooses to lose 7 electrons, so its electron configuration will be the same as neon, tanggalin niya lahat yan, or to gain just 1 electron. Bakit? Ano yung next noble gas? Yung argon. Ano yung atomic number ng argon? 18, di ba? So that means sa ating electronic configuration, if you have 18 electrons, that means noble gas na uli yun. Na? So yan. So remember, 10 itong kay neon, plus you have 7 here. 17 na yon. E di isa na lang kulang, no? Magiging argon na yon. So pwede siya mag-gain ng isang electron para ang kanyang electronic configuration ay maging argon. So ano yung mas madali? Ang mas madali ay tumanggap ng isang electron, no? So what will happen is that chlorine will accept 1 electron, 3s2, 3p. Instead of 5 na yan, magiging 6 na yan. No? So yan, since tumanggap siya ng isang electron. And that actually corresponds to the noble gas configuration na argon. No? Yan, magiging, na yan, magko-correspond na yan sa noble gas na si argon. No? So yan. Ano pa yung consequence? Since chlorine gained 1 electrons, it will lose, it will gain a negative charge. No? So, tumanggap siya ng isang electron, so magiging negatively charged siya. No? So, ano napapansin natin? No? So, one way for atoms to be stable is by giving off and accepting electrons. No? So, pag may nag-give off ng electron, may magiging stable. Pag may nag-accept ng electrons, may magiging stable. And what do we know about these charged particles? We know that positives are attracted to negatives, di ba? Yung positive attracted sa negative. So if we combine those two compounds, no? If we combine positively charged particles and negatively charged particles, we can have the so-called ionic compound, no? So, ano mapo-form natin? Ionic compounds, no? So, saan gawa yung ionic compounds, no? Ionic compounds are composed of positively charged atoms, no? And we call them cations. And negatively charged atoms or anions, no? So that means we can combine positively charged particles or atoms, pwede ring molecules, no? So we can combine those positively charged stuff with negatively charged particles, no? In order to make an ionic compound, no? So ang positive tawag natin doon ay cation, ang negative ang tawag doon ay anion, no? So again, let's check na ano yung ginawa natin. Ang ginawa natin is that dito tayo na. So we started with the concept of atoms wanting to be stable. One way for them to be stable is to lose electrons or to gain electrons na. So okay, so yan, pwede siya mag-lose ng isa, pwede mag-gain ng isa, so on and so forth, no? Just in order to get the noble gas configuration. And that happens for your ionic compound, no? So yung mga ionic compound, bigay tayong example, yung asin sa bahay, no? So nagbigayan ng mga electrons yon, kaya nag-e-exist sila as stable salt, no? So yan yung idea, no? So you have your ionic compounds when atoms releases or accepts electrons, then they become stable. Okay? So yun yung clue. Pero ito, balikan natin yung pinagagawa natin. So look, no? Ang effort, 'di ba? Nakakatamad. Kasi ako mismo, tinamad ako pag nagsusulat niyan eh. Ilang beses ko na 'to sinulat ngayong linggo. This is my third time writing the same thing, no? So yun, so medyo nakakatamad, 'di ba? I know. Kaya may shortcut, no? Ano yung shortcut, no? Ayun ay pinakilala ni Lewis, no? So si Lewis, he is investigating, no? He's an American chemist, no? Around 1914s. Uh, in-investigate niya yung concept of bonding, no? And then yun, he came up with the Ionic compound and the covalent compounds, no? So sabi ni Lewis, pag ganito yung gagawin natin, aabutin tayo ng siyam-siyam, no? Sabi ni Lewis, it would be better na lang if we represent the valence electrons, no? Valence electrons daw yung ipapakita na lang natin instead of the whole electronic configuration. So let's start with lithium. 'Di ba ang lithium, ang kanyang electronic configuration ay helium 2s1. Ano yung valence electron niya? Edi 1, no? So I will represent that as 1 dot, no? So 1 dot. O tropahin, no? So yan. So ano pa? Let's have chlorine. So ilan yung valence electrons ni chlorine? Tignan natin yung kanyang ano. Tignan natin ang kanyang electronic configuration. It contains 7 valence electrons. 2 plus 5, 7 na. So I can represent it using 7 dots. No? So lagpas siya sa 1 dot. No? So 7 dots. So paano ko ilalagay yung 7 dots? Sabi ni Lewis, you start by placing 1 electrons around the atom first. No? So 1, 2, 3, 4. It doesn't matter kung clockwise or counterclockwise. No? Kasi narinig ko sa bata ko nung high school daw sila counterclockwise. Wala namang ganong batas, no? Kahit anong okay lang. Basta tama yung sagot, no? Okay, so yan. So you start by placing single electrons first, no? Sa 4 sides niya. Then yung excess, you start pairing na, no? So yan. So 4, 7 yung kailangan, 5, 6, 7. Okay? So yan, so 1 dot, 1 valence electrons, 7 dots, 7 valence electrons na. So ibig sabihin ba sir, kailangan namin gumawa ng ganyan muna para malaman kung ilang dots? Not really. Tingin tayo sa periodic table. As you can see, we have 8 major groups in the periodic table, excluding the D and the F orbital. So hindi natin papansinin tong D and F orbital. So we will focus with these groups na. Ayan, focus tayo dyan. Okay, so ito yung group 1. So the group 1, ano yung valence electrons nila? Isa. Diba remember yung sodium, 2s1. Yung 3s1. Yung lithium ay 2s1. No? So that means for the whole family, for the whole group, isang valence electrons lang yung ending nila. No? Ito naman, for the second group, ano yung ano niyan? Ending nila, S2. 2s2, 3s2, 4s2, something something, s2. Okay. So that means this family, the second group, will have 2 valence electrons. This group naman will have 3 valence electrons. By the way, group 3 yan, no? Sinama lang niya itong, ang tawag dito? Transition metals, no? So, ayan, no? So, 3 valence electrons dyan. So, group 4, 4 valence electrons yung katumbas niyan. Kasi tingnan nyo yung electronic configuration, S2, P2. So, pag pinag-add mo yon 4, di ba? Galing, na. Then, yan. Group 5, 5. Ano yung electronic configuration kasi? S2, P3. So, pag group 5 ang iyong atoms, 5 valence electrons, 5 dots. Group 6, ito yung 6 valence electrons or 6 dots. Group 7, ito yung 7 valence electrons or 7 dots. And group 8, ito yung 8 valence electrons or 8 dots with exception to helium. Bakit hindi 8 si helium? Kasi, ano yung orbital na meron siya? 1s lang. So, the s orbital can only hold 2 electrons. Okay, so, kailan mag-start mag-8 kay neon? No? So, 8 na yan pababa. So, in summary, instead of writing this whole stuff na nakakapagod isulat and nakatamad bilangin, so instead of writing that stuff, we can represent the movement of electron for the atom to be stable using dots, no? So again, ano yung idea natin kanina, no? Si lithium, magbibigay yan ng electron. Si chlorine, tatanggap yan ng electron. Ilang electron ibibigay ni lithium? Tingin tayo dito. It will give off its 2s1 electron. Isang electron ipapamigay niya. Si chlorine, ilang electron tatanggapin niya? Isa din, no? So, pwede natin i-represent yung pagbigay and pagtanggap ng electron using the dots, no? How? Okay, this is the valence electron of lithium. Pwede natin ipakita yan as ipapamigay niya papunta kay chlorine. So, ito na yung part naman ni chlorine na tatanggap siya ng isang electron. So, pwede natin ipakita yon visually ng parang ganyan. No? So, what will happen is that lithium will no longer have valence electrons, meaning non-stable na siya. Si chlorine naman, on the other hand, ano mangyayari? Yung isang additional electron niya na binigay ni lithium ay enough for it to be a noble gas configuration. No? Yung isang electron lang kailangan di ba? So, anong pwede natin gawin dito? No? Ang pwede natin makuha ang idea is that, number one, we can shorten the way we write the stability of the atoms. No? Hindi na natin pwede isulat yung mga yan. Ay, pwede isulat, no? Pero hindi na kailangan isulat tong mga to. No? Ano na lang kailangan gawin? You just write the dots, no? Now, by the way, this is called the Lewis dot symbol. Lewis dot symbols. So, all you have to do is to write the Lewis dot symbols. The number of dots correspond to the group of your element, no? Pag group 1, isang dot. Kapag group 2, dalawang dot. 3, tatlong dot. 4, apat na dot. So on and so forth until group 8, no? Na 8 dots, no? So we can show the stability, no? Paano? Paano natin malalaman na stable na ang atom pag ganyan? Ito yung dalawang visual cue. If there are no dots around the atom, stable yan. Pag 8 yung dots around the atom, stable din yan. No? So, yun yung idea. No? So, stable. Yan. So, ganun lang yung idea. So, if this loses the electron to chlorine, then mawawalan siya ng dots. No? So, 0 na yung kanyang valence electron. So, stable na yun pag ganun. No? Because it assumed the configuration of the noble gas that it succeeded, no? Yung sinundan niyang noble gas yung kanyang pinapakita, no? Na configuration. So si chlorine naman, ganun din. Pag walo na, ang problema naman kay chlorine ay walo na yung dots niya, no? So the 8 dot corresponds to the 8th group in your periodic table, which is the noble gas na, no? So by having 8 dots, that mean na noble gas ka na, no? So ganun yung idea, no? So medyo kulang pa yan, no? Kulang pa yung ating diagram. Ano yung kulang? Charges. Okay. So lithium lost 1 electron. So ibig sabihin yan, it will gain a positive 1 charge. Every time you lose an electron, you will gain a positive charge, no? Si chlorine naman, it accepted 1 electron. So meaning nun, magiging negatively charged na siya. Okay, then what do we know about the charged particles? Positives are attracted to negatives and then they will form the ionic compound. No? So ito yung basis ng ionic compound such as yung salts, asin sa bahay. So makikita nyo yung asin pag tumingin kayo mamayang dinner, nagbigayan sila ng electron kaya sila nag-e-exist. No? Okay, so ganun sila ka-loving. No? So yan. Okay, so that's the concept of ionic bonding. No? So yan. So, syempre, practice pa tayo. Worksheet na. Ayan, may sagot na. Burahin ko. Wala kayo nakita. Okay, so practice tayo. So let's represent first the Lewis dot symbols. No? By the way, may nakalimutan ako sabihin. Palagi ko ito nakakalimutan. Ewan ko kung bakit. Kung mapapansin nyo, ang isang rule for stability is that walang electron or walo yung electron. No? Pag walo yung electron, ang tawag doon ay octet rule. So ano yung idea kapag octet rule? Kailangan ng 8 dots, 8 electrons for the atom to be stable. Pwede rin naman wala, no? Pero pagdating sa drawing ng Lewis structure, kailangan i-octet rule, no? So, yung lab na yung bahala doon, no? Teka lang. Or if you want, gusto nyo maki-sit in sa classes ko sa lab, although tapos na kami, no? That means wala na kaming meeting next week. Tinapos ko na lahat this week, eh. Kung gusto niyo makinood ng lessons namin sa lab, di sa YouTube lang, no? Ando naman yung mga lab class ko, eh. Magkakasama na lahat. So, yun. Kung gusto niyo lang, no? Manood kayo doon sa YouTube. Andun yung mga lab class ko. And yun nga, since wala akong class next week sa lab ko, gagawa ako ng mga Khan Academy style videos, no? Parang yung ginagawa ko ngayon. Pero syempre, English na yun. Siyempre, hashtag Team Payaman. De joke lang. So, yan. Tagal ko nang di rin nag-vlog, eh. So, anyway. So, yan yung idea, ha? So, octet rule kapag 8 dots na. Bakit ako gagawa ng vlogs ng lesson? Kasi malapit na midterm nyo, oy. Malapit na. As in, 4 weeks na lang. So, good luck. Alam ko kaya nyo yan. Mga magagaling naman kayo, eh. Diba? May mga nakaka-perfect nga sa quiz, diba? Okay lang yan. So, sige, dito tayo. So, ano yung technique natin? Wag na natin isulat yung electronic configuration kasi ako tinatamad ako. Ano na lang. We draw the Lewis dot symbols. Predict how many electrons must be gained or lose to follow the octet rule or the stability, no? Okay, so sasagutan ko yung tatlo. Sir, ano name nyo sa YouTube? J-Chemi. No, ito. Pero yung class recording natin, di nyo siya makikita sa channel, no? Kasi naka-hide. Para makita nyo yung class recordings, punta kayo dito sa Canvas. Teka lang. Ayan, Canvas. Punta kayo sa announcement. Pinost ko yun dito, eh. By the way, extend ko yung deadline ng quizzes nyo. Okay. Then, punta kayo sa announcement. Then ito, recorded class discussions on YouTube. Uy, organic chem, no? So, andito yung mga lessons ko. Ayan. Andyan yung lab, MT lab. Andyan yung lecture. Andito yung classes natin minsan. Kung gusto nyo mag-org chem na, edi sige, org chem kayo, no? Pero BS chem yung approach ko dyan, eh. Wala lang, gusto ko sila pahirapan. Para masaya, diba? Eduk kasi. Kailangan kung magtuturo sila, kailangan alam nila yung org chem talaga. So, puntahan nyo na lang yung post ko sa, yung post ko sa Canvas. Andun yung link para mapanood nyo yung class recordings natin. And isave nyo na yung playlist na yun. Every evening nag-update ako nun. So, yan. Okay. So, hindi naka-public yung videos, eh. Hindi naman sila nagbabayad ng tuition fee. So, tayo lang yun, nakakaalam nun. Okay. So, ito. So, ito yung tawag dyan. Ito yung mga atoms natin. We are going to draw the Lewis dot symbols and let's predict how many electrons must it gain or lose to follow the octet rule, no? Okay, so start ako. Lithium. Sinagutan ko na, eh. No? So, alam ko na, 1 dot yan. Kasi group 1 siya, di ba? So, 1 dot. And question, how many electrons must it gain or lose? It would be easier for it to lose this electron. No? Pwede ipamigay na lang niya yan. Stable na siya. So, ano yung sagot? 1 dot and lose 1 electron to follow the octet rule. Yan. So, tapos na ako. O mamaya kayo naman, no? Magre-raise kayo ng hand. Tapos, use your microphone para marinig ko yung answers nyo. Sasabihin nyo yung number of that, tas kung ilan yung ilulose at i-gain, no? So, sagutan ko muna until C. Letter B, chlorine. So, si chlorine, look at your periodic table that can be found in the 7th period, 7th group, no? So, meaning nun, since nasa 7th group siya, may 7 dots siya. So, 1, 2, 3, 4, 5, 6, 7. 7 dots. So, how many electrons must it gain or lose? Pwede niya tanggalin yung 7 or tumanggap na lang siya ng isa. So, ano yung better? Tumanggap ng isa. So, it will accept 1 electron. Stable na yan. Phosphorus. Group ano yan? Group 5. So, 5 dots. 2, 3, 4, 5. Okay, so 5 dots. Would it accept or gain electrons? Bilangin natin. Pag ilulus niya yung 5 electrons, effort. Ilan na lang ba kulang niya? 3 na lang. So, ang better choice ay yung 3. So, it will gain 3 electrons. No? Gain 3 electrons. Ayan. So, with that, no, tulungan nyo na ako hanggang letter N. So, anyone can raise your hand, no? And then, you tell me, sige, Nikolai. Nikolai, ilang dots?
3 po.
Totropahin, jojowain. Ayan, totropahin. Ayan, 3. Then, would it lose or gain?
Lose
Ilan?
3. Lose
3 electrons. No? So, 3 electrons itatanggal niya para siya ay maging stable or maging octet. No? Ayan, so thank you, Nikolai. Strontium. Strontium. Mariel Vanessa. How many dots?
2 dots po.
2 dots. Gain or lose?
Lose 2 dots po.
Lose 2 electrons. No? So, yan. Para maging stable. So, thank you. Sunod. Sulfur. Joanna Angela. Ilang
6
dots?
dots po.
6 dots. 1, 2, 3, 4, 5, 6. Lose or gain?
Gain 2 electrons po.
Okay, so gain 2 electrons. Kasi dalawa na lang octet na siya, no? So, yan. So, thank you. And silicon. Maria Cristina Andrea.
4 dots
Po?
4 dots.
4 dots, no? 4 dots. Gain or lose? Ito yung question.
Parehas.
Wow, pwedeng mag-gain, pwede rin mag-lose, no? So, pag ganong case, no? Sir, ano yung factor na ano kaya yung pwedeng maging basis natin dyan? Ganito, tignan nyo na lang yung electronegativities, no? Na-discuss naman natin itong nakaraan. If the atom is electronegative, then it prefers to accept electrons. 4 electrons for carbon. Since this silicon, siya ay less electronegative than carbon, then may tendency si silicon na mamigay ng 4 na electrons. Ito si germanium, mas may tendency itong mamigay ng 4 na electron kaysa kay silicon. So, ano na lang yan, case-to-case basis na. But yun, marami siyang option na. So, yan. So, ang electronegativity ang factor na ika-count natin doon. Asan na ako? Oxygen. Meron na. Oxygen, sige. Nicole Celia. Nicole. Sorry. Nicole pala basa dyan na. Tama ba?
Ako.
Nicole? Ay, sorry ah. So, yan. Ilang dots?
Ano po? 6 po.
6 dots, no?
Apo.
Gain
Mag-gain
or
po siya
lose?
ng 2.
2 electrons ang i-gain, no? So, yan. And magnesium, may diesel.
Meron po siyang 2 valence electron.
So, 2 dots. Gain or lose?
Tapos, maglulus po ng 2 electron.
Okay, so it will lose 2 electrons for it to be stable. Okay, so thank you, Florine. Let's have James Bernard.
7 po yung
7 yung dots.
Apo.
Tapos, would it lose or gain?
Magigain po siya ng 1 electron.
1 na lang. Kasi isa na lang. 8 na siya, no? So, yun. So, yun yung sagot na. Aluminum. Okay, so thank you, James. Aluminum. Sige, let's have may diesel ulit. No?
Aluminum po, meron po siyang 3 valence electron.
Tatlo. Then, gain or lose?
Maglo-lose po ng 3 electron.
Lose 3 electrons, no? For it to be stable. Okay, so thank you. Yung sulfur na ulit-uli, no? Hindi ko na kasi tinignan eh. Potassium, let's say, Kyla, Maureen.
1 valence
One
electron.
dot.
1 dot po.
Lose or
Then,
gain?
lose 1.
Lose 1 electron for it to be stable. Okay, so thank you. Nadigay na ako. Let's have bromine, last one. Last one, bromine. Cedric John.
7 po, sir.
7. Lose or gain?
Gain 1 po.
Gain 1 electron para maging stable. Okay, so yun lang yung concept na. Ngayon, ano yung gagawin natin ngayon? Ito yung gusto ko, ito yung gusto ko ipagawa. Kaya may mga nagko-comment sa Canvas. Ang daming notif ng Canvas eh. May Gcash. Sana may pera. Okay, so gawin natin ito na. Ang gagawin natin this time is that we will combine our cations and anions, no? I mean the metals, no, to form ionic compounds, okay? Isip muna ako ng pwede pagpares, no? May isi-ship tayo. Siyempre, madali lang muna sa akin. Nanonood na si Cedric. Ayan. Okay, so anyway. Na and ano kaya? Oxygen. Ano kaya? N na lang. And last one, K and BR. Urong ko lang to sa taas. Oops, wala. Ay. Wait lang. Urong ka sa taas. Yan. Okay, so ito yung task natin. So our task, ako yung sa A and B. Tapos kayo na bahala sa iba. Okay, so ano gagawin niya? Ito yung gagawin niya na lang sa canvas, no? So, sige, sagutan ko na until C. No? Tapos yung iba, parang siya yung maging activity nyo na lang at home. Kasi continuation tayo next week, no? So, 2 weeks naman yung allotment dito. Okay, so let's have A, B, and C. Ano gagawin niya dito? So I will do, what I will do is I will represent the atoms with its valence electrons, no? So lithium 1 dot, chlorine 7 dots, no? Okay. So paano ko ipapakita yung transfer of electrons, no? So mag-draw lang kayo ng arrow. Then yan. Then yung resulting atoms mo, no? So yan. Kung may iba kayong color na lapis or ibang color na lapis tuloy, ball pen, or if you have tech devices such as stylus, Apple Pencil, edi maging colorful. So yan, so ano gagawin ko? I will represent my atoms with Lewis dot symbols, no? Yung dami ng dots nila that will correspond to my group number. Then ipapakita ko my electron is moving from lithium to chlorine, no? To fulfill the stability requirement, no? So as lithium loses 1 electron, magiging positively charged yan. Chlorine gained 1 electron, so negatively charged yan. Then paano natin malalaman yung chemical formula niyan, no? So ang chemical formula niyan would be the number of atoms required, no, para ma-complete ma-complete yung yung stability requirements nila. So, isang lithium lang yung kinailangan for the Cl, no? So, the formula would be LiCl, no? So, you always write the metal first before the non-metal, no? So, let's have another example sa gagawin nyo. Na and oxygen, no? Na, isa lang yan, is 1 dot. Oxygen, 6 dots. Ayun. So, lagay ko yung electrons ni Na. Yung isa, ilalagay ko dun kay oxygen. Wala, paano yan? Tignan nyo, si oxygen, kulang pa siya ng isa, no? So, ang pwede kong gawin is that I will write another Na, no? So, mag-write ako ng isa pang Na, which will be my other source of electron. Then, ilalagay ko yung kay, pangit ng curve ko, teka lang. So, ilalagay ko yung kay oxygen, no? So, to complete the stability, no, it required me 2 sodium atoms, no? It required me 2 sodium atoms, no? And 1 oxygen atom to complete the octet rule. So, ano mangyari? This sodium lost 1 electron, so it will be positively charged. This sodium lost 1 electron, so it will be positively charged. This oxygen gained 2 electrons, so it will be negative 2 in charge, no? So what will be my chemical formula, no? So my formula would be, since I have 2 Na, Na2 yan, no? I will represent the number of atoms using subscripts, no? So dalawang Na, Na2, and isang oxygen, O. Na2O. That's the formula for Na and O, no? na ionic compound, no? And last one, I will have aluminum and nitrogen, no? So ganito lang yung gagawin nyo, no? So kaya nyo na to sa bahay. Nasa bahay naman kayo. Ayun. Okay, so aluminum and nitrogen. Ilang dots for aluminum? Tatlo. 1, 2, 3. For nitrogen, that's 5. 1, 2, 3, 4, 5. Okay. So, I will show the transfer of electrons from aluminum to nitrogen. Kasi aluminum will lose 3 electrons, na. Lagay natin doon. Ito din, lagay natin doon. And ayun. Uy, sakto. So, it required me 1 aluminum atom to complete the octet of nitrogen, na. So, wala nang electron si nitrogen. Si aluminum pala. Si nitrogen, kompleto na siya ng 8 electrons na requirement, no? Okay. So, papakita ko yan as ganyan, no? Since aluminum lost 3 electrons, it will be positive 3 in charge. Nitrogen gained 3 electrons, so it will be negative 3 in charge. So, what will be my chemical formula? Basta yung chemical formula yan. So, ano magiging chemical formula ko? Yung number ng atoms na kinailangan ko to complete the stability requirement, no? So, it required me 1 aluminum atom and 1 nitrogen atom. So, this is the chemical formula for the compound with aluminum and nitrogen atom, no? So, yan, ALN, no? So, yan yung gusto ko gawin nyo. Show the electron movement, no, for letters D to I. Then, post nyo na lang sa discussions page sa Canvas, no? Parang itong ginawa ng mga batang to. So, sisend ko na lang dito sa GC yung send ko sa GC yung items, no? So, ganito yung ginawa nila, discussions. Section, let's say section 4. Kahapon to eh. Ayan, papakita nila yon, pinapakita nila yung movement ng electron, dots, no? Actually, mali nga sila, no? Hayaan mo na. So, ganun na. Papakita niyo yung movement ng electrons, then yung corresponding charges, no? Then the formula for that compound, no? Okay, so yun lang. Screenshot ko. Then, Teams. Ayan, so save nyo na lang. So, yun yung task nyo. Yung nasa baba ng starting sa D to I na. So, post nyo na lang doon sa discussion sa Canvas. Okay. Ay, ito na yung ginawa namin sa labo. Drawing. Diba? Ang saya-saya. Okay, so anyway, let's proceed. No? So, what we have discussed is the ionic bond. No? So, in ionic bond, what you can observe is that meron tayong cations. Sino ba yung mga cations? Usually, sila yung metals. So, sino ba yung mga metals sa periodic table? So, punta tayo sa periodic table na. Ba't ko sinara? So, ito yung periodic table natin. Asan dyan yung metals? Ito, no? Yung nasa left side ng ladder. Ito yung ladder na to. Yan yung ating mga semi-metals, di ba? So, that means all these metals, no? All these atoms, no? They will serve as our cations, no? And yung natira, itong mga to, nasa right side, ito yung mga anions, no? So, onti lang pala yung anions, no? Yes po. Okay? So, ganun. So, usually, ionic compounds are created by combining metals and non-metals, no? So, yun yung general thought, no? You have your metals and the non-metals, no? So, ngayon, may isa pang type ng compound, no? We call them covalent compounds, no? Covalent compounds, no? So, what's the difference between covalent compounds and, what's the difference between covalent compounds and ionic compounds? Again, for ionic compounds, ano meron? You have your metal and your non-metal, no? For covalent compounds, puro non-metal to, no? Non-metals yan usually. Bigay tayong example. Oxygen gas. Ano formula ng oxygen gas? O2. Nag-e-exist yan. Yes. Kasi kung wala niyan, patay tayo. Ano pa? Hydrogen gas. No, that exists. Yes. Walang metal. Paano sila nagsasama? Mamaya na. No. Ano pa yung mga nag-e-exist? Nitrogen gas. Ayan. Kailangan yan sa hangin, nitrogen gas. Kasi kung yung Earth ay puro oxygen gas, pag may nagliyab somewhere, for example, ngayon may nagliliyab sa California, wildfire, ibig sabihin nun, pag walang nitrogen gas sa hangin, puro oxygen gas, sunog na yung buong mundo, no? So, hindi naman ganun eh. So, yung nitrogen gas yung pampa-stabilize ng hangin, no? Para hindi masunog agad yung mga bagay-bagay, no? Okay. So, yan. So, these three compounds are just some few examples of covalent compounds that exist, no? Marami pa. Malalaman nyo yung pag nag-draw na kayo ng Lewis structure in your laboratory, no? I don't know if nag-start na kayo, no? Pero sige lang, no? So, yan. Ang question dyan, ganito. Di ba, sir, pag non-metals, sila yung nag-gain ng electron? Most of the time. Opo, sila yung nag-gain. So, paano sila, sir, na-form, no? Walang nagbibigay eh. Tumatanggap lang sila. So, yun yung dilemma nila, no? Sabi nila, yun yung dilemma ni Lewis, no? Kaya siya gumawa ng Lewis structures, no? Imagine, no, magka-problema ka lang, gumawa ka na ng ganun, tas nanalo ka pa ng Nobel Award, no? Saya. So, yun. So, yun yung question nila, how come that these molecules are formed, no? Given that wala namang metal, walang magbibigay ng electron, meron lang tumatanggap ng electron. So, ito yung keyword nila, sharing ng electrons. Yun daw yung ginagawa ng covalent compounds, no? So, instead of fighting for extra electron, they are just sharing the electrons that they have. So, as they share the electrons that they have, nagiging stable sila, no? So, nagsasama na lang sila para maging stable, no? So, 'yan. So, paano natin, sir, yan dinodraw, no? So, ganito, no? Para rin siyang Lewis dot symbols, no? So, let's have hydrogen gas. Sige, hydrogen gas. Dalawang hydrogen atom yan, and each hydrogen atom will have one dot, no? Kasi it is in the first group, no? So, paano nila isi-share yung electron, no? Kasi ganito, isipin nyo, kapag si hydrogen, hihilahin niya yung, hihilahin niya yung electron ni kabilang hydrogen, ano mangyari? Magiging 2 dots yung hydrogen na yan, ito, mawawalan siya ng dangal, no? Wala na siyang electron. So, ano yung electron configuration niya? Wala. Pwede ba yon? Pwede, pero pangit, no? So, ganun yung idea, no? So, nawalan siya ng electron configuration. So, hindi siya magiging stable. So, anong pwede gawin? Ganito. So, walang mga agaw. Nagkasundo sila, wag mo ako agawan ng electron. No? Nagtagalog talaga sila, no? So, ano gagawin nila? Instead, they will form bridges, no? Pag nag-form sila ng bridge, ang tawag dyan ay yung chemical bonds, no? Chemical bond. No? Ang tawag dyan ay chemical bond, no? And that bridge, no, would allow the electron to travel sa dalawang atoms, no? So, pwede yung electron na yan mapunta doon, tapos itong electron mapunta doon, so on and so forth, no? So, by creating a bridge, no, to connect the electrons, they form chemical bonds, no? And that chemical bonds allows the existence of hydrogen gas, no, for example. So, yan. So, as they combine their two electrons, their two valence electrons, they form chemical bonds, no? Kung saan sa chemical bonds, dyan dadaloy ang ating electrons, no? Dyan sila magfo-flow. So, paano natin malalaman if satisfied na ang requirement for stability, no? By the way, we can rewrite that as ganito, no? Ayan. So, remember na lang at always at each end may tig-isang electron. Ito yung question. Paano po natin malalaman ang stability kung satisfied na? Okay. Ang pwede nyong gawin is ganito. You draw a parabola with the equation. So, gagawa ka ng parabola enclosing the end of the chemical bond. No? So, ito yung chemical bond, di ba? Sasakupin mo yon. No? Mamili ka ng atom. For example, ito, gusto ko to. So, gusto ko tong hydrogen na to. So, I will draw a border enclosing the bonds, no, attached to it. So, meaning nun, sasakupin ko yung bond hanggang dulo. Ayan. So, mukha siyang mukha na. So, ayan. Bilangin natin yung electrons na sakop niya. Ilan yung electrons na nasakop ng curve na yan? Isa, dalawa. Every time you see a single bond, automatic dalawang electrons agad yon. Isa, dalawa. So, that means for this hydrogen atom, it already contains 2 electrons na, no? May dalawang electrons na sa paligid niya. The question is ganito, is that enough for it to be stable? The answer would be yes. No? Bakit dalawa lang? Akala ko ba octet? Ang sagot ay 1s orbital lang kasi meron for hydrogen, no? Always remember, 1s lang meron. Ilan electrons kaya ng S? 2 electrons. So, hanggang 2 lang yung pwede kay hydrogen. So, yan. So, by connecting the bridge, 2 electrons are now joined, no? So, if you count the number of electrons for this hydrogen, dalawa, satisfied na yung requirement, no? Satisfied na siya niyan, no? So, stable na yan, no? So, let's have another parabola, no? Check naman natin tong kabilang hydrogen, no? So, again, so paano tayo gumagawa ng curve? Sakupin ang bond, no? Hanggang dulo. Ayan. Ilang electrons ang nasakop niya? Isa, dalawa. So, there are 2 electrons around this hydrogen atom. Satisfied na ang requirement? Yes, no? Because again, for hydrogen, it only requires 2 electrons because it contains s orbital only. Okay? Yan. So, keep in mind yung mga ganun, ha? So, yan. So, by doing chemical bonds, no? Each atom now share equal amounts of electrons needed for the stability, no? So, yan. So, tigdalawa na sila ng hydrogen. So, stable na sila, no? So, that will exist, no? So, nag-exist na yung hydrogen gas, no? Okay. So, tingin pa tayong example. Oxygen gas, O2. Okay, so yan, oxygen gas, 6 valence electrons. Ano pwede gawin, no? So, walang mag-aagawan ng electron dyan, no? Ano pwede gawin? They can connect their single electrons to form bonds. No? So this oxygen will connect the electrons to that electrons ng kabilang oxygen. Ganon din dito sa baba. No? So, yan. So they can form two bonds, no, in between them. Ayan, so two bonds or double bonds, no. So yan yung pwede nila gawin, no. So they can form two bonds, no, to maximize the sharing of electrons. Then let's check, no, kung satisfied na ang requirement for stability. For this oxygen at the right side, sakupin ng bond, bilangin ang electrons na meron na. 1, 2, 3, 4, 6, 8. Again, every line, dalawang electron. So, 2, 4, 6, 8. So, satisfied na ang octet rule for oxygen. So, tingin tayo sa kabilang oxygen. Yan. Satisfied na ba ang octet rule? Bilangin natin. 2, 4, 6, 8. So, 8 na yung electrons around it. Again, for every line, dalawang electrons. 2, 4. Okay? So, ganun na. 2, 4, 6, 8. So, octet na to. So, by sharing the electrons, they complete the octet, no? They satisfy the octet rule. Hence, it is stable. So, stable na siya. Sana all. Last one. N2. Last one. Matapos na ba tayo? Medyo malapit na, no? Okay, so last one. So, walang mag-aagawan ng electron dito. Pareho silang nitrogen, no? So, ano pwede nila gawin? They can connect their single electrons, no? To form chemical bonds, no? So, to form bridges. So, yan. 1, 2, 3. So, they can use up to 3 bonds pala, no? To maximize the stability. So, ngayon, bilangin natin kung satisfied na ang octet rule. Let's look at this. Ilang electrons na meron around the nitrogen? So, this is 2, 4, 6, 8. Satisfied na ang octet. Okay, let's look at this one naman. So, ilang electrons na around the nitrogen here? 2, 4, 6, 8. So, octet na. Satisfied na ang octet. So, ano lang yung point natin, no? The point is, chemical covalent compounds, no, share electrons. By what? By what means? By forming chemical bonds, no? So, they form chemical bonds for them to share the electrons kasi walang gustong mamigay. Walang metal eh. Puro non-metal yan. So, yan. So, they will form chemical bonds. Then, as they form chemical bonds, they satisfy each other's requirement for stability. Yung octet rule, no? Of course, exemption dyan si hydrogen, no? Kasi dalawa lang yung kaya niya, no? So, yan. So, yan. Ano pa yung pwede natin makuha ang idea? In covalent compounds, no, or covalent molecules, we can have up to 3 types of bonds. No? Pwedeng tatlo yung bonds. Single bond, dalawang electrons lang ginamit. Pwedeng double bond, apat na electrons yung ginamit. Pwede ring triple bond or tatlong electrons ang ginamit. No? So, yun. Ang goal lang naman dyan is to maximize the sharing of electrons. No? So, marami pang uri ng ganyan. So, feel ko si laboratory na yung bahala dyan kasi ang haba niyan. No? Yung mga ganyan-ganyan, ayan. So, tapos na kami dyan eh. So, panoorin nyo na lang sa YouTube kung gusto nyo manood. No? Kayo bahala. No? Pero i-discuss din yan eh, laboratory. No? So, yun yung idea. No? So, our molecules can have single bond, double bonds, and triple bonds to maximize the sharing of electron for stability. No? Okay, so let's have heteromolecules. Meaning ng heteromolecules, magkaibang molecule, magkaibang atoms. No? So let's have HF. Okay, HF. Sige. Ang pa kaya? HCl na lang. HCl. No. So HCl. Draw natin yung kanilang Lewis dot symbols. Digay ako ng digay. Ayan, so 7 dots, 7 valence electrons, 1 dot, 1 valence electron. So, chlorine wants 8 electrons para satisfied siya sa octet rule. Si hydrogen, gusto niya ng 2 electron, no? Para maging helium ang kanyang electron configuration. Bawal na snatch ni chlorine itong electron na yan. No? Again, hydrogen is a non-metal. No? Ganun din naman si chlorine, non-metal yan. So, since we have 2 non-metals here, what we can form is the chemical bonds. No? Yan. So HCl. Okay, so yan. So we have this molecule for HCl. Mga basic lang tayo sa lab na yung complex Lewis structures. No? So yan. Okay, so ano ba mapapansin natin dito? No? So this time, let us look at the electronegativities of the atoms. No? Tignan natin ang electronegativity ni hydrogen pati ni chlorine. No? Sir, bakit? No? Wala lang. Kasi by knowing the electronegativity difference, we can predict the type of bonds that we have. No? Pwede natin malaman kung anong uri ng bond ang meron tayo. And 3 yung uri ng bonds. No? Dito na ako sa part na yan. Download nyo pala itong worksheet na to. Kasi, itong lecture guide. No? At ito yung ginagamit ko talaga since then. Even nag-aaral pa ako, may ganito na ako. No? So, yan. Okay, so, ano sabi ko, no? If we have heteroatoms, that means 2 different atoms are combined in a molecule, we can have different types of chemical bonds. No? So, 3 yan. We have non-polar covalent compound, non-polar covalent bond, no? The polar covalent bond, and the ionic bond. Let's differentiate the 3. If you have non-polar covalent bond, ano yung implication nun? Non-polar. Ano meaning ng polar? Walang positive, negative charge. No? So meaning, for non-polar covalent bond, the distribution of electron is the same. So yun yung pwede nyo kailangan isipin. No? Ano uli meron? Same distribution of electrons. So walang uneven electrons. No? So balance lang yung electrons. Pero if the atom is bonded with more electronegative atom, meaning nun magkakaroon ng distortion sa electron distribution. No? Magkakaroon ka ng distorted electron distribution. Hence, you will have a polar covalent bond. No? So, sir, ano itsura nun? Okay, so, let's look at the electrostatic potential of Hf. No? So, parang HCl lang din yan. So, let's consider this. No? So, Hf. No? So, among the 2 atoms, fluorine is the most electronegative. No? No doubt na yan. Pero kung nagdo-doubt kayo, tingin kayo dito sa table na to or sa periodic table nyo. No? May electronegativity values doon. So, tignan nyo si fluorine. Ang value niya ay malabong 4. Pero 4.0 yan. No? Yan, 4.0. Ang electronegativity ni fluorine. Meanwhile, si hydrogen ay 2.1 lang. So, what does that imply? Again, when we say electronegativity, this is the tendency of your atom to withdraw electrons. Yun yung tendency na manghihila siya ng electrons. Bakit? Kasi gusto niya ng electrons. Gusto niya maging noble gas. No? So, yun yung idea. Fluorine really loves electron. That's why it will pull the electrons of hydrogen towards itself. Kaya nakikita natin yung distorted shape sa electrostatic potential. Pag nakita nyo yung red, that means doon maraming electron. Sa blue part, we don't have too much electrons. Wala masyadong electron. Andito yung karamihan ng electron. So what will happen? Ganito. Pag nagsama-sama yung mga nega, yung mga electrons, ano mangyayari sa charge? No? Magiging negative side itong kay fluorine. So magiging negative side si fluorine side. Si hydrogen side, since wala tong electron, magiging positive side yan. No? So parang nagiging magnet, parang nagiging polar yung ating molecule. No? That's why, if we have big difference between the electronegativities of different atoms, we can have polar molecules. No? So when we say polar molecules, there are uneven distribution of electrons. No? So hindi pantay yung pagkaka-distribute ng electron. So the side bearing the highest electronegativity will have the negative charge. The side bearing the bearing the lowest electronegativity would have the positive charge. No? So yung side na mataas ang En, dun yung electrons. Sa mababa yung electronegativity, dun yung positive, walang electron. Okay? So yan. By just checking on the electronegativity difference, we can actually see if the bond is polar. No? Pero again, for covalent bonds, no? Covalent bond to, no? Sa ionic compound, ano yung nangyayari? Balik ulit tayo dito. Sa ionic compound, tignan nyo. Si chlorine, ang electronegativity niyan ay 3.5, no? Kinabisado na yun, no? Si lithium hindi ko alam, hindi ko kabisado. Si lithium ay 1. Ay, 3.0 lang pala. Sino yung 3.5? Oxygen ata yan. So, yan. Burahin natin yan. So, si chlorine ay 3.0 ang electronegativity, 1.0 for lithium. So, ano yung idea? That means chlorine will really abstract the electrons. Aagawan niya ng electron, si lithium. So, ano nangyari? Nung kinuha niya yung electrons ni lithium, naging negative charge siya. Ito naging positive, no? Ganon din sa covalent molecules, no? So, namabansin natin sa covalent molecules, sana yun? So, sa covalent molecules, medyo ganon din yung idea, no? Fluorine is the most electronegative atom than hydrogen. So, hihilahin niya yung electrons towards itself, no? Pero, walang full transfer of electron. Remember that. Walang full transfer of electron. So, ibig sabihin, hindi talaga negative charge yan. Pati hindi talaga positive charge. So, anong charge meron dyan, sir? Partial charges lang, no? Partial charge, no? So, yung meaning ng parang 8 na yan, no? That is actually a Greek letter delta. Okay, so yan. So, anyway, so ano yung sinisimbolize niyan, no? Kasi kapag nilagay natin yung full negative, pag nilagay natin yung full negative pati full positive, meron tayong ionic compound pag ganyan eh. Ionic yan eh. Pero again, covalent molecules to. So covalent molecules meron tayo. So for covalent molecules, we do not have full charges. Rather, we have partial charges now. Partial charge lang ang meron tayo, no? So walang matatanggalan ng electron. Manghihila, yes, pero walang mapuputol, no? So ganun yung idea. So the side na manghihila ng maraming electron would bear the partial negative charge. The side bearing the lowest electronegativity would bear the partial positive charge, no? So dalawang pole yan, the positive pole and the negative pole. So we have polar molecule. So, yun yung idea. So, again, so tingin ulit tayo dito sa electronegativity difference. If same yung distribution, non-polar. Non-polar, meaning balance lang, equal-equal. No? Non-polar yung molecule. If we have distorted electron distribution, that means we have polar covalent molecules. Polar covalent bond. No? Pero, kapag mas malaki na yung difference ng electronegativity, electrons will be pulled, no? So, pag na-pull na yung electron, ionic compound yung katumbas niya, no? Oh, may nag-raise ng hand. Any questions? May naka-raise na hand. O, kanina pa siya. Kanina pa ata to, na. Kanina pa yan. Kala ko may tanong. But yun, so anyway, yun yung point, no? So, yung hilahan ng electrons, tatlong extent yan. Pwedeng walang effect. So that means non-polar yung molecule. Pwedeng medyo malakas, distorted yung electron distribution. So you will have partial charges. Pwede rin naman yung matindihang malaki na yung difference ng electronegativity. So may pull na talaga ng electron, no? Once electron is pulled, you will have ionic compounds, no? So full yung charges mo dyan, no? Pag full yung charge, positive talaga yan, pati negative. Pero kapag partial charge, you use the Greek symbol, partial negative, partial positive. Para siyang 8, no? Yan, so ganun. Okay, so yan yung goal natin. Medyo last part na tayo, no? So medyo patapos na tayo. So let's classify the following bonds as ionic, polar, or covalent, no? And medyo may examples pa dyan, no? So pwede nyo ituloy yan, no? So kayo na bahala dyan, no? Basta you have your worksheets with you naman, no? You have this lecture guides that I made 2 years ago, no? Noong bata pa ako. Bata pa rin naman ako ngayon. So yan na. So yan, so let's classify the following bonds, no? HCl, no? So classify natin if siya ay ionic, polar, or covalent, no? Actually kahit di mo na i-drawing. HCl. So sir, paano natin ma-classify? So we have a number line here wherein may certain values, no, to determine the range of the type of bond, no. Between 0 to 0.4, pag yan yung difference ng electronegativity, you have non-polar compounds, no. Pag 0.5 to 1.8 na yan, you have polar compounds, no. And anything na 1.8 pataas ay ionic bond na. So tingnan natin kung ang HCl ay polar covalent, ionic, or non-polar covalent, no. So paano yan, sir? Ganito lang, no. Let's solve for the change in, the difference ng electronegativity. So si hydrogen, ang kanyang electronegativity ay 2.1. Si chlorine ay 3.0. Sir, saan malalaman? Dito sa periodic table, no? So yun, tignan nyo si hydrogen, 2.1. Si chlorine, yan, 3.0 na. So yan. So you just obtain their electronegativities, 2.1, 3.0. Then you subtract the big number, no, and the small number. So big muna bago small para positive yung positive yung answer. Delta En meaning nun yung difference, no. So 3 minus 2.1, so the difference is equal to 0.9. So 0.9, tingin kayo sa number line. Asan yung 0.9 dito? Somewhere dito sa gitna, no? So nandito siya sa gitna. So that means since nandito siya sa gitna, you have a polar covalent bond, no? So that means your molecule HCl is polar. Yan na yan. That's why muriatic acid dissolves in water, no? Yung HCl, nadi-dissolve yan sa tubig, no? So yan. Pag naglilinis kayo ng mga bagay-bagay sa bahay, no? So gumagamit ka ng muriatic, natutunaw siya sa tubig, no? Okay, so KF, no? Kasi water is polar, no? Share ko lang. KF. So let's have KF, potassium and fluorine. The bond in KF. Okay. So tingin tayo dito. Hindi ko naman kabisado to eh. So potassium is 0.8. Ayan, 0.8. Fluorine is syempre 4. This is 0.8. This is 4. So delta En. 4 minus 0.8 cannot be, no? 3.2. So 3.2. So 3.2 yung difference nila, no? Okay, so tignan natin sa number line kung nasan yung 3.2. Oops, lumagpas, no? Lagpas siya sa 1.8, no? So that means you will have ionic compound here, no? So ionic compound yan pag ganun, no? Okay, so let's have another example. CC bond. Ito technique, no? Pag same atom lang yan, the answer is non-polar. Pero kung gusto nyo patunayan sa sarili nyo, edi sige. Carbon is 2.1. Carbon is 2.1 as well. No? CC lang yung gusto natin eh. So, kunin natin yung difference niyan. So, that's 2.1 minus 2.1, edi 0. So, asan yung 0? Ayun, nasa pinaka left side, non-polar. No? So, the CC bond is non-polar. Okay, so you can do that, no? Practicein nyo na lang to, no? Hindi ko siya ipapapasa sa canvas, no? Kayo na bahala, no? If you want to read all of this, go, no? Kasi andito na lahat ng lessons for this chapter. Kumpleto yan, no? So, yan. So, kumpleto yan hanggang dulo, no? Ayan, no? May lessons din ako ng atoms, molecules, ion, no? So, yan. So, yan. So, pwede nyo sagutan yan. Pwede nyo ituloy yan, no? So, kayo na bahala, no? Choice nyo naman yan. So, yun. So, I will stop dito na sa part na to, no? So, that's how you predict the type of bond, no? So, ano yung mga types of bond natin? Non-polar, polar, and ionic, no? For ionic, there is a big electronegativity difference. Malaki yung difference. So, the electron is pulled, no? Hinihila na yung electron ng electronegative atom. Kaya nagkakaroon ng charges, no? The positive and the negative charge, no? For polar covalent bonds, may pull pa rin ng electron. May hilahan ng electron. Pero not strong enough, no? Hindi siya ganun kalakas para baklasin yung electron sa atom, no? Unlike ionic compounds, no? So, hindi siya nagbabaklas ng electron. Ano lang? Hihilahin niya lang, no? Parang tug of war lang. So, ganun lang. So, the tug of war of electrons, yung pull of electrons, that causes distortion in electron distribution. So, magiging ganito yung mangyayari, no? So, magiging iba yung difference magiging iba yung shape ng iyong molecule. May side na maraming electron, may side na walang electron, no? So, yung side na may electron, yun yung partial negative charge. Yung side na walang electron, yun yung partial positive charge. Again, sino yung side na partial negative? The more electronegative atom. No? So, the more electronegative atom is partial negative. The least electronegative atom would be the partial positive. No? But if the difference of your electronegativity is within a tolerable range, 0 to 0.4, wala masyadong polarity na nangyayari. No? So, same lang yung distribution. Hindi madidistort yung bond. No? So, ganun lang. Ano lang siya? Chillax. No? So, yan. So, those are the types of bonds. No? Do I have to remember this, sir? Kahit wag na. Yes po, as much as possible, walang negative. No? Kaya big number always minus small number. No? Or kung negative yung masolve mo, absolute value mo na lang. No? Basta big number minus small number always. No? So, ganun lang. Big electronegativity minus small electronegativity. So, yan, ganun lang. And last part, no? To finish this day, ay, so wakas, makakapagpahinga na rin. Dipole moment, no? So, ano yung dipole moment, no? So, the dipole moment is the moment of dipole, no? Ano ba yung moment, no? Sa physics, pag sinabing moment, yun ay direction. Dito na lang ako sa blank slide, no? So, sa physics, pag sinabing moment, yun ay direction. Yan ay direction. So, kung naalala nyo pa yung STEM physics nyo, edi yan, direction yung moment. So, dipole, this pertains to the polar molecule. No? Okay. So, bakit may direction yung polar molecule? Remember, because mayroong difference sa electron pool. Diba? Let's have HCl. The electronegativity of Cl is 3.0, hydrogen is 2.1, no? So ano yung intuition natin? The electrons will be pulled from hydrogen to chlorine. Hihilahin ni chlorine yung mga electrons papunta sa kanya. So how are we going to signify the dipole moment? No? So ganito lang yan. Makikita nyo yung ganyang arrow. No? So ano meaning ng arrow na yan, sir? So ano meaning niyan? The arrowhead points to the most electronegative atom, which is Cl. That means yung electrons pupunta kay Cl. No? So sir, ano meaning ng positive na yan dyan sa dulo? Yung positive dyan sa dulo, that tells you that that side is the partial positive side. No? So ito yung partial positive side and yung electrons niyan pupunta kay Cl. No? So again, the arrowhead tells you the direction of electrons. No? Kung saan papunta yung electrons. So for this bond, papunta sila kay Cl. Papunta sila doon sa Cl. Okay. So, yun. So, yung side na walang electrons that will bear this positive symbol, then continuous arrow to Cl. No? So, yan. So, ibig sabihin, papunta doon yung electrons. No? That's the dipole moment. No? And siguro more of that dipole moment once you are able to draw the Lewis structures. No? So, siguro upload ko na lang yun sa YouTube as a separate video. No? So, yan. Ano na lang. Gym Academy na lang na. So, ganun na lang. So, hindi ko alam kung nakapag ano na kayo Lewis structure. Nakapag Lewis structure na ba kayo? Hindi pa. Hindi pa ba? Nakapag Lewis structure na ba kayo? Or hindi pa? Nakapag-Lewis structure na pala kayo. Okay. Pag nag-molecular geometry kayo, pwede nyo i-apply uli yung dipole moment. No? Again, yun, ano tawag doon? Yung ating atoms, no, may different electronegativity sila. So, the more electronegative atom will pull the electrons. No? So, kaya ganyan yung arrow. Positive dito sa atom na hindi electronegative. Then, yung arrowhead, papunta siya sa more electronegative atom. No? So, you can actually combine the ideas ng dipole moment with your molecular structure such as this. No? So, pwede mo i-combine yung mga ideas na yan to predict the polarity of the molecule. No? Pero I don't think kasama yan. Hindi ko alam kung kasama yan sa coverage. No? So, kung gusto nyo malaman kung polar ba yan or hindi, edi dipole moment lang. No? So, but anyway, yun lang. No? Hanggang dun lang muna tayo. No? Ano gagawin natin next meeting? Next meeting, we will proceed in naming compounds. So, I want you to download this handout then. Atom, molecules, and ion. Nasa nasa discussions. Ito yung rules kasi ng naming. No? So, dito yung rules ng naming sa baba. Ayan. So, as much as possible, kailangan ba nyo ba magkabisado? Hindi. For lang to? Familiarization lang talaga. No? So, yan. So, kabisaduhin nyo na lang yung mga, familiarize nyo na lang pala sarili nyo sa mga rules. No? So, di-discuss naman natin to next meeting. The best PowerPoint for this one is yung, syempre, yung ginawa ko. Benta ko lang yung ginawa ko. No? Syempre, ako gumawa. Effort ako dun eh. So, ang PowerPoint na maganda gamitin for the naming part is yung nasa chapter 4. Ako yung gumawa ng chapter 4 eh. So yan, ay sa lab, sa lecture pala. Lecture chapter 4. So yan, just sa chapter 4 lecture, naming kasi yung first part niya na chemical formula and nomenclature. So, download nyo na lang yan. And yun. So, andun yung rules, no? Actually, alam ko may recording din ako dyan, nung nagsasalita ako dyan. So, yan. So, with that, we're done with the first part of our discussion. No? Any questions or okay na tayo? So, yun lang yung summary, no? Ano yung ginawa natin today? We discussed the concept of bonding. So, we started with the electronic configuration, no? Kasi again, atoms want to be stable. So, meaning nun, gusto nila maging noble gas configuration. So, they have lots of options to gain or to lose electrons. If they give off electrons or gain electrons, then you have ionic compounds now. But if your atoms share the electrons, you have covalent compounds. In covalent compounds, you can have single, double, or triple bonds. No? If in case you have heteroatoms, no, such as HCl, magkaibang atoms, there could be a difference in electronegativity. So ito yun. No? So yan. The difference in electronegativity can give you an idea about the nature of the bond. It could be nonpolar, it could be polar, or ionic. No? So ano gagawin? Just look at the table. Meron din naman ito sa periodic table nyo, so don't worry. So look at this table, get the electronegativity, then you subtract it with the bigger electronegative atom, no? So parang ganyan, big electronegativity minus small electronegativity. Then pag nakuha nyo na yung difference nila, tingin ka dito sa bond, sa number line, then you can decide no, kung anong type ng bond yan. Kung polar, ionic, or non-polar. No? Okay? So if you have polar covalent bonds, then you have a dipole moment. So what is a dipole moment? So in polar bonds, ang kwento lang ng dipole moment is the direction of electrons. No? So we signify the direction of electron using this arrow, positive on the least electronegative atom, then arrowhead for the most electronegative atom. That means papunta sa chlorine yung electrons. No? We can also add the charges. No? So partial negative for chlorine, partial positive for hydrogen. No? So meaning ito yung walang electron, andito yung maraming electron. No? So yan. So we're done. Any questions or okay na tayo? Okay, so feeling ko okay na naman kayo dyan, no? So, ayan. So, if you have any questions, don't hesitate to ask me, ha? So, yan. So, starting next week, since wala akong lab class muna, pahinga muna ako. Dahil tapos na namin yung structures, no? Siguro, wait na lang kayo sa mga catch-up videos, no? On different topics sa class, no? Hindi lahat ng nasa class ay di-discuss ko dun sa videos na yan. Yung mga important lang, such as Lewis structures, geometries, concept ng bonding, isotopes, no? Yung calculations na meron tayo, yung measurements, no? Kasi malapit na yung midterm, no? So para mas marami kayong reviewer, no? Kasi ang goal natin, lahat kayo ay mataas ang grade sana, no? So yan. So yan. So with that, I'm done with my objectives today, no? So okay.